Today we're going to review how to multiply using generic rectangles or the distributive property. The first two examples that I will work it with generic rectangles and distributive property. And then after that, we're going to stick with the distributive property. If you would prefer to use generic rectangles the whole time, you are more than welcome to do that. All right, let's get started. First problem. If you have a monomial 6x and you're going to multiply by a binomial 4x squared minus 2. Well, if I do this with a generic rectangle, I have a monomial times a binomial. So I'm going to use a rectangle that is 1 high and 2 wide. I put my 6x here, and I put my 4x squared here, and my minus 2 right here. Well, I multiply the length times the width to find the area of my rectangles. So 6x times 4x squared would be 24, and then x times x squared would be x to the third, because there's 3 x's there. If I pull the 6x across and multiply this length times width to find the area of this rectangle, I would get negative 12x. So what would my answer be? My answer would be 24x to the third minus 12x. I already had my area as a product to begin with, so I just found my area as a sum. Now, if I want to do that same problem, but use distributive property instead, I would do this. I would take my monomial, and I'm going to multiply it by the first term in the parentheses. So 6 times 4 is 24, and x times x squared is x to the third, because when I multiply like bases, I add the exponent. 6x times negative 2 would be negative 12x. And notice that I get the same answer that I got down here. All right, that's a monomial times a binomial. Let's do one that is a binomial times a binomial. Okay, using a generic rectangle this time, I have a binomial times a binomial, so I need 2 rectangles by 2 rectangles. So on my length, I have x plus 3. And on my width, I have x minus 4. Okay, now I want to find the area of all of the squares, or all of the rectangles. So I have length times width. I have x times x, which is x squared. I pull this x up to the top, because they're the same length. And I have x times 3 is 3x. I pull my 3 across this way. And I have a negative 4 down here that I'm going to pull up. And I have length times width here, which would be negative 12. I pull this x across here, and I have x times negative 4, which would be negative 4x. Once I fill in all of my rectangles, I can add them together. Again, this is my area as a product. I am getting ready to find my area of this rectangle as a sum. So I'm going to add up all the parts. I get x squared. Now 3x and negative 4x are like terms, so I can add those together and get negative 1x, or just negative x, because 3x minus 4x is negative 1x. And the only thing I have left is that negative 12. So there is my sum, my area as a sum. Now, if I use distributive property, I'm actually going to use distributive property twice. So I'm going to take this x and I'm going to multiply it by the 2 terms in the other parentheses. So I'm going to say x times x. That would give me x squared. Then I take the x and I multiply by negative 4. That would be negative 4x. Then I multiply the second term in my first parenthesis by everything on the other parenthesis. So I say 3 times x is 3x, and I have positive 3 times negative 4 is negative 12. Now you can see that I still have like terms here, so I have one more step, and I add collect like terms. I get x squared minus 1x minus 12. And then you notice that I get the same answer that I got when I did it with my generic rectangle. So this method is distributive property. This method is generic rectangle. And you could do it however you would like. Okay, we're going to do a couple more examples, and then I'm going to let you try some on your own. Let me turn the page. Number 3, this time we're going to multiply with distributive property only. Unless you like to do it with the generic rectangle, then you can do it your own way. Here I have 5x squared minus 1 times 2x plus 9. I have a binomial times a binomial. This is my area as a product. I want to find the area as a sum. So I take my 5x squared, I'm going to multiply it by the first term in the second parentheses. So there I get 10. And how many x's do I have? I have 2 x's here and 1 x here. I have a total of 3 x's. When I multiply like bases, I add those exponents. Then I take my 5x squared and I multiply it by the second term in the parentheses, and that would give me 5x squared times positive 9 would be positive 45x squared. Then I'm going to take the second term in my first parentheses, and I'm going to distribute that to everything in the second parentheses. So this times that, negative 1 times 2x would be negative 2x, and negative 1 times positive 9 would be negative 9. Now, when I go to collect like terms, you're going to notice that all of these terms are different. This one has 3 x's, this one has 2 x's, this one has 1 x, and this one has 0 x's. So I'm actually finished. This is my simplified answer. I cannot simplify that to a trinomial because I do not have any like terms. All right, number 4 is one that these are the longest ones when you have something like this. If you have 2x minus 5, you have a binomial, and you multiply it by a trinomial, negative 4x squared plus 2x minus 3. Now, if you did this with a generic rectangle, you would have to have a rectangle that was 2 high and 3 across. So if you decide to do it with a generic rectangle, it's still possible. It's just a little bit bigger than what you're used to. All right, let's go ahead and multiply. We're going to take this first term, and we're going to multiply it by everything in the second set of parentheses. So I'm going to have 2x times negative 4x squared, which would be negative 8x to the third. 2x times a positive 2x would be a positive 4x squared. And 2x times negative 3 would be a negative 6x. So I'm halfway done. Now, I'm going to take this second term, this negative 5, and I'm going to multiply it by everything on the other set of parentheses. So negative 5 times negative 4x squared would be a positive 20x squared. And negative 5 times a positive 2x would be a negative 10x. And negative 5 times negative 3 is positive 15. Now, when you look at that, you can see that you have some like terms. I have an x squared here, and I have an x squared here, and I have a x here and an x here. So I have two things that I can combine, two different like terms, sets of like terms. So I'm going to rewrite my negative 8x to the third. I have 4x squared and 20x squared, so I have plus 24x squared. And then I have negative 6x and a negative 10x. That's negative 16x. And the last thing that I have is that plus 15. So there is my final answer. That is my area as a sum. Now there's one other type of problem that I wanted to work. And a lot of times people will do this one incorrectly. If you have 2y minus 3 raised to the second power, do not get that confused with something like this. 2y times 3 to the second power. That means you raise everything inside the parentheses to the second power. And we can do that when everything's all multiplied together. But we don't have multiplication inside. We have subtraction. So you cannot raise the 2y to the second power, and you cannot raise the 3 to the second power. You have to do something else. This is a binomial squared. What does that mean? That means we have two 2y minus 3's. So I'm going to write this as 2y minus 3 times itself. I'm going to make this problem look like this problem up here. Now I could use distributive property twice or use my generic rectangles. So 2y times 2y would give me 4y squared. 2y times negative 3 would give me negative 6y. And then I start all over again, and I use the second term, and I multiply it by everything over here. So there I get negative 6xy again. And negative 3 times negative 3 is positive 9. Okay, then when I look at that, I see, hey, I have like terms here and here. So my final answer is going to be 4y squared minus 12y. I'm collecting like terms, so I just add them together, plus 9. And there is my area as a sum. Okay, now on the next page, I am going to give you these 4 problems. And what I want you to do is I want you to pause the video, and I want you to try these 4 problems on your own. And then when you guys are ready, then you can resume the video and I will work them out and you can check your answers. So you can choose to use distributive property to multiply these, or you can use generic rectangles. It is up to you. So I would like you to pause the video right now, and then you can restart it when you guys are done. Okay, I am going to work these problems now. So you check your answers and make sure that you did them correctly. All right, on this first one, I have a monomial times a trinomial. So if you did a generic rectangle, you should have a 1/3 rectangle. And distributive property, we are just going to take this times that. That would give me negative 3x to the 4th. This times that would be plus 6x squared. And negative 3x times positive 6 would be negative 18x. When I look at my answer, I see that all my exponents are different, so I do not have any like terms, and I am finished. So I'm going to box my answer. Hopefully you got the same answer. Okay, number 7. We are multiplying a binomial times a binomial. So if you're doing a generic rectangle, you would have a 2x2 rectangle. When I multiply, I have my minus 3x times positive 4x. I get negative 12x squared. Negative 3x times negative 5. The negatives cancel, and I get plus 15x. Then I start all over again with this second term right here, this plus 2. Plus 2 times 4x is plus 8x. And 2 times negative 5 is negative 10. This time, however, I have like terms, so I'm not done. So when I collect like terms, I get negative 12x squared. 15 plus 8 is 23. And then my x stays the same, minus 10. And there's your answer. Hopefully you got it right. Okay, number 8. I have a binomial times a trinomial. So if you used a generic rectangle, you're going to have a 2 by 3 rectangle. All right, let's multiply this. I'm going to take my first term and I'm going to multiply it by everything in the other set of parentheses. So I get 5x to the third. X times negative 4x would be negative 4x squared. And x times positive 1 would be positive x. Then I take my negative 6. Make sure you take the negative sign with it. And I multiply this way. I'm going to say negative 6 times 5x squared would be negative 30x squared. Negative 6 times negative 4x would be a positive 24x. And negative 6 times positive 1 would be negative 6. So when I collect like terms, I have 5x to the third. That's the only one I have. I do have a negative 4x squared and a negative 30x squared. So when I add those two negatives together, I get negative 34x squared. Then I have plus x and plus 24x. So that would be plus 25x. And my last term is negative 6. So there is my answer for number 8. Okay, number 9. Here I'm going to take my binomial squared, and hopefully you guys did not get x squared plus 25 because you totally missed your middle term. You write it twice and you say x minus 5 times itself. And then if you use a generic rectangle, you're actually going to have a square. You're going to have x and a minus 5 times x and a minus 5. Distributive property, we multiply here, we get x squared. Here we get negative 5x. Here we take this negative 5 and we distribute it. We get negative 5x again. And negative 5 times negative 5 is positive 25. Okay, let's finish this problem. We have x squared. These are both negative, so I add them and keep the same sign. I get negative 10x plus 25. There is my area as a sum, simplified. Okay, that was some those were some examples using distributive property. So you have a worksheet. Keep your examples out to help you work through the worksheet, and hopefully you'll have a better idea on how to use distributive property and generic rectangles. That is all for today.